Hello, calculus students. It is time for the Unit 2 review. So let's get started. In this first one, it says picture the graph of the first derivative f prime of x. So what you need to do is make sure that you label this really big, that this is f prime of x. So I'm drawing this on the side just because you can kind of see that in pencil. I'm going to do the rest in marker, but because I don't want it to bleed through to the back, I forgot to print this on two-sided copies, or I'm sorry, on one-sided. So this is f prime of x. This graph is all about the derivative. And it says of a polynomial function. As soon as you see anything with a polynomial function, you should be thinking continuous. Yeah, and I'm happy about it. Such that f of 3 is equal to -1. Okay, so right now, f of 3 is equal to -1. This is a point. And it's on the graph of f of x, not on the graph of f prime. So if I went over to 3, I can see this is not at 1, because this is saying from the function f of x. Okay, so perform an analysis on all values from -infinity to infinity. And I need to figure out where f of x is increasing or decreasing. So whenever I perform an analysis, make x, f prime, and f of x. And I figure out where this function is increasing and decreasing. So whenever I have an algebraic expression of any sort or a function actually given to me, what I do is find the derivative, set it equal to 0. Here I have a derivative. It's already been set equal to 0 in a couple places, here, here, and here. So my critical values are going to be at -2. So I'm going to go -infinity and -2. And then I can see at -2, f prime is 0. Then I'm going to go from -2 to 1. Because at 1, right there, I have another 0. 1 to 2. Because at 2, I have another 0. And then you can go on 2 to infinity. You don't have to make this chart every time you see something that looks like this, but in this particular question, it's saying make a table, so I'm going to make a table. And I want to figure out whether f of x is increasing or decreasing. That's this part right here, which means I want to figure out if f prime is positive or negative. And now I can just look at the graph. I usually pick out something in between -infinity and -2 and plug it into to f prime to see if this is going to be positive or negative. But right here, I can just look at this graph. I can see between -infinity and -2, that's all this area here, that f prime is negative. -2 to 1 is positive. It's above the x-axis, so anything up here is positive, anything down here is negative. From 1 to 2, I can see it's negative again, then 2 to infinity, positive. That's not always going to be the case where it goes back and forth, but in this one it is. Which means f is decreasing, increasing, decreasing, increasing. Decreasing to increasing, increasing to decreasing, decreasing to increasing. So at x equals -2, there's going to be a relative min. Increasing to decreasing, and I can see it right here. There's going to be a relative max at x equals 1. At x equals 2, there's a relative min. And then it says find all x values of relative extrema. So what I would say here, if I'm justifying my answers, I would say f of x is decreasing on the intervals from -infinity to -2. And I would also say from 1 to 2. And the reason would be as f prime of x is less than 0. Or you could say negative, and you could write this in a different way. You could say f prime of x is less than 0 on these intervals, therefore f of x is decreasing. Anything like that. Same thing with increasing. So I'm going to go up here, increasing and increasing, so I say -2 to 1. And 2 to infinity as f prime of x is greater than 0. And then it also says find all x values of the relative extrema. I couldn't actually find the coordinates even if it asked me to do that because this isn't the function f of x, it's the function f prime, and I don't know what those values are. Like here, the minimum is x equals -2. I have no idea what that function value is. Same thing for x equals 1, same thing for x equals 2, because none of those are given to me. So I'm going to say f of x has relative minimums at x equals -2 and x equals 2. And this is where you have a choice. You can either say as f of x changes from decreasing to increasing, or you can say as f prime changes from negative to positive. Yeah, I'm almost out of room, but I'm gonna go up. Next thing is f of x has a relative max at x equals 1 as f prime of x changes from, and I have to be careful, I said f prime, so I've got to be thinking positive to negative here. If you said f of x, you would have to say increasing to decreasing. Okay, so that's number 1. Let's keep going. So for number 2, the marker is kind of running out, so I might get another one, but number 2. So right now in this one, I've got polynomial function f of x. So f of x. And I want to know when f prime is positive, negative, 0. So what I'm going to do, I'm gonna get a new marker, see if this one works better. I'm gonna say, I'm actually gonna say these things first. So I'm gonna justify, this is number 2. I'm gonna justify, oh, this marker is much better. F of x is increasing when f prime of x is positive. So I'm justifying first. So now I can go to f of x and say f of x is increasing when f prime of x is positive. Okay, I want to know when f prime of x is positive. So I'm going to look for when f of x is increasing. I can see that happens here. And it also happens here. So I would say from, this is kind of hard to tell because it's really like negative 2.1 or something. The graph isn't awesome. So I'm going to say this occurs on the intervals, negative 2.1, and this would definitely be something that you'd be able to give the exact answer if this were on a test. From 2.1, and again, there's no arrows on the end. There really should be if I want to go the whole way to infinity. Okay, so then we've got f of x is increasing. Likewise, I want to know when f prime of x is negative. So I'm going to say f of x is decreasing. When f prime of x is negative. I could say is negative or less than 0, it doesn't matter. And I would say this occurs on the intervals. So because this is f of x, I'm going to look, where is it decreasing? And I can see that's happening from negative infinity to negative 2.1, like here. And then it also occurs here, from 0 to 2.1. So I figured out when f prime is positive, negative. 0 is, let's think about what this means. So f prime of x is equal to 0 when this is the derivative. The derivative is the same thing as the slope of the tangent. So the slope of the tangent equals 0 when f of x has relative extrema. And you could say mins or maxes. These occur, and I can see it happens here, here, and here. So at x equals negative 2.1, x equals 0, and x equals 2.1. I justified all my answers. I'm good to go. Next. Oh man, we're into the second page. It's an exciting day.